I hope you're all having a great morning still. I am Erlend Hoel, and I am here today to tell you about and show you also how to leverage the Armo platform for Kubernetes security. I thought that before I do that, I just wanted to recap a little bit what Kubernetes is and how we do it in Orange Business. So even if you've not heard of Kubernetes or containers until today, I'm sure you'll be familiar with virtual machines. That's a technology that became very popular in the early 2000s and basically allowed you to subdivide and partition your hardware in order to get more performance and scalability out of it. So you would run an operating system on several instances on the same hardware, which let them exist in isolation from each other. So containers are basically that, minus the OS. So they're even more lean and cost-effective. And so what a container is basically an application that has been packaged together with all of its dependencies into a format, an image as we call it, that can be deployed anywhere you want. Legend has it actually that the founder, or one of the founders of Docker, came up with a concept when he was looking out of the window and he saw a shipping container being loaded onto a ship from a train. And he thought to himself, you know, look at these things. They go all over the world, from trucks to trains to ships. Why can't software be the same? Well, now it is. And Kubernetes, of course, is the thing that orchestrates all these containers for you. So it's in charge of spinning up new containers if old ones die. It lets you run upgrades seamlessly without downtime. Yeah. What we're using in Orange Business is something we've called MKS, Managed Kubernetes Service. That's something we've built on top of something else called K3S, which is a fully compliant, certified Kubernetes distribution, lightweight, high performant, with a local flavor. We've also built that on top of an immutable OS. That means an operating system that cannot be altered after it's been started, which has some pretty great security and scalability implications. And we do this in our sovereign cloud, quickly and easily. We really only need to know how powerful and how redundant do you want your solution to be, and then we're off to the races. And the whole thing is tuned for GitOps. Now, what is GitOps? GitOps is something that came out of DevOps, which itself is a methodology or a school of thought that says that software development and software deployment should pretty much exist together in the same space rather than be handled separately by different teams. I'm just going to have a quick drink of water. GitOps is basically that, taken to the next level. I've written here a little cheekily that the documentation is the code. It used to be a joke by programmers that the code was the documentation. It was so well written that you didn't need to document it. Well, now we've come full circle. When we deploy something, we actually write the specification for what we want and publish that to Git, and then that becomes what happens. The specification in Git is not just a documentation, it is the source of truth. So we define it, review it, and then publish it. And Argo CD, or Flux, which you also could use, we've got Argo CD as our CI/CD pipeline, takes the changes and deploys them in the cluster. So one way that that could look is here. You have probably your code and your development pipeline, which then results in artifacts, so images in your registry. And then we set up some shared platform. It doesn't have to be much more complicated than a Git repo, where you can publish your Helm charts, which then will pull images from your registry, or a global one if you want, a public one. And then Argo CD, running on our clusters, will check that configuration in the Helm chart and pull images from where they are needed and deploy them on the cluster. It really is that easy. Now, is it too easy? As we all know, when you're trying to do something complex quickly, there's a chance of introducing problems. as we will see later. I say this with foreknowledge. Sometimes when you're trying to get something to work, you have to alter settings and permissions until you actually can get it up and running like you want. And then when it finally does work, you may not quite remember what you did to get there. That's where Armo comes in. So Armo is a security and compliance scanner, which is built on top of Kubescape. And Kubescape is simply the open source free version that Armo has created. It's now a sandboxed CNCF project since December 2022. And we run that on-prem in our sovereign cloud. As far as I'm aware, we're the only ones that do that worldwide. What Armo does is to provide a scan of all cluster components and resources. So that means both your images, which might have vulnerabilities, especially if you've written them yourself, but also your config maps and all sorts of settings. Oh, and best of all, it provides human sensible output, a remediation that you can easily understand and then implement in your Git repository. So what you're seeing now, assuming that works, is a Git repository where there are 4 services defined. The bottom one is the one we'll be following today. We've called it important service, just to highlight how important it really is. So that's the manifest, declaring a deployment, an ingress, a service, and a config map. And it specifies that there should be 3 replicas running at all times. And here's the Argo CD view of it. So this is Argo showing you what we already know, what's running in the cluster, the 4 services, the second of which from the left is the important service. And clicking into that, we see the same things as you could tell from the YAML manifest. The config map, the ingress, the service, and also you can see to the right there that it's running 3 replicas. So there's everything has been done as we wanted. We're happy, we're up and running, things are great. But then we ask Armo, how does things actually look? This is the Armo interface. It's a web-based one, as you can tell. From the dashboard, you can pretty much choose which clusters. We've only got the one defined at the moment. And you can also select which compliance frameworks you want to use. I believe there's even external ones that you can download if somehow you're not happy with the 6 or 7 provided alternatives. So what we're first going to look at is the attack path, which is just a way of zooming in on what is a potential vulnerability, among possible compliance errors or misconfigurations you have, what could actually be exploited by an attacker. So as we click into that to get a bit more info, we see that our web service indeed does have a risk of denial of service. Oh, and there's a code there that you see that you can click. Anytime you see a number like that, you can click it and it'll take you to the Armo website, where there's usually a good explanation of what the recommendation is all about and an example of how things could, maybe should look. Okay, this is the vulnerability section of the Armo platform. So that's basically vulnerabilities in the container image itself. Now for this demonstration, we're using an image that we built. So we're not casting shade on anybody else's code. We actually purpose-built this to have some vulnerabilities so we could show you. It also shows you if there is a fix available, and if so, which version you'll need to get in order to enjoy the benefits. So that was vulnerabilities. Here we are looking at compliance. Now that's more to do with misconfigurations, permissions, stuff like that. You see that we've selected 5 compliance frameworks along the top. The leftmost one is the Armo Best. That's also the most stringent one, so we're only scoring 75% at the moment. But we'll see what we can do by looking at the actual errors that are reported and go about doing some improvements. So that's the web service, that's the namespace web, which is the one we'll be looking at today. I don't know if that went a little too fast. Okay, that's probably where I want to be. So you can see right away that Armo is highlighting the fact that the password for a database appears in plain text. I mean, it's masked here, but when we go back to the YAML that I showed you earlier, and maybe some of you noticed it already then, it's written in plain text, which is obviously not best practice. As we hover over that, we see that the recommendation is, of course, to use a Kubernetes secret instead. So define the credentials as a secret rather than have it as plain text. Other things is resource limits, not defined. The image itself does not have a signature. The run as user and group has been set to 0, which is the super user. That's probably not needed. Privilege escalation has not been specifically disabled. And finally, the automatic, sorry, went a little too fast for me. Yeah, and some SC Linux settings for compliance. Read-only file system also should explicitly be set to true. So this is Armo's report of all the things that it found in our cluster, which deserves attention. Now back to the YAML file that we were looking at earlier. Maybe you caught it earlier, but you certainly now can see that we have defined run as user 0. We've got capability system admin set. There's the password in plain text. It's all terrible. So we've, of course, cheated a little bit. We've got a merge request ready to go. We kind of knew what Armo was going to report. So that's ready to merge. It's been approved by my colleague. And here you see the actual changes, which then mirror what we were told by Armo to do. We're also bumping the container image version to one that has fewer, not none, but fewer vulnerabilities in it, as well as the compliance issues that were raised, the sysadmin capabilities and the run as user ID. There, so that's being merged, and that's happening in Git, as you see. And immediately we jump over to Argo CD, and you can just see the tail end of that deployment being updated. To the right there should be, yep, that's pods being restarted. And if you look really closely at your screen, you'll see that most of the things have been running only a few seconds. So that's gone and done behind the scenes with a simple click. So now that we've done that, now that we've actually improved the thing that Armo reported, we'll run another scan just to see if things look a little better now. Which, of course, we have every reason to suspect that they should. But now you get to see how we do a scan as well. So I click the scan. You choose then which frameworks you want to, compliance frameworks you want to apply. All seems a safe bet, so I'm doing that. And off we go. Now, this usually takes a bit more than a minute or so, but since we have the benefit of magic here today, I can already jump us ahead, or so I think anyway. Whoa, look at that, 77%. So that's an improvement of over the previous scan because we addressed all the issues that Armo raised. These are the vulnerabilities still being reported. The image is still not signed. That's okay, we knew about that. And you'll discover that now there's a new compliance error, which was kind of being masked by a previous setting. I think. All right, we didn't get to see that one in detail, but and you now see that where we previously had 5 vulnerabilities in the actual container image itself. If we refresh that, it should come back with 4. So, better. Still not perfect, but that's also part of what CI/CD is. It's a continuous improvement, continuous deployment. So you don't have to fix everything at the first go. You just continuously iterate and make it better